I want you to imagine, just for a second, that you are prepping for the absolute most dangerous day of your life.
Oh, boy.
Right. A day where just, I don't know, a single misstep, like a turned valve in the wrong direction, or maybe a misread gauge where that could be totally catastrophic.
Yeah, stakes are incredibly high.
Exactly. And to get ready for this day, someone just hands you a 20-page paper manual.
Wow. Just a paper manual.
Yeah, a binder. They just pat you on the back. They tell you to read it carefully, maybe have you take a little multiple choice quiz, and then they point you toward this massive machinery and say, all right, you're good to go.
I mean, it sounds crazy when you put it like that, because the gap between, reading about how to survive a catastrophic emergency and actually having the motor skills to survive one, it's just a massive chasm.
It really is.
Because reading a manual, that uses a completely different part of your brain than the part that takes over when alarms are screaming and, like, smoke is filling a room.
Right, your brain just goes into panic mode. Yet, for a very long time, that has essentially been the standard for industrial safety training.
Oh, for decades.
You read the binder, you take the quiz, you check the compliance box. But today, we are diving into something that is trying to completely obliterate that old model.
And it is about time.
Seriously. So our sources for this deep dive are a July 2026 press release and an incredibly detailed white paper from a company called EON AI Ventures.
Yeah.
And the paper is titled The EON Situation Room, Turning the Industry's Worst Accidents into Verified, Simulatable Training.
It's a really bold title, but the premise is what really demands attention here. I mean, they are essentially attempting to digitize human survival instincts.
Which is wild. So our mission today is to explore how the high-stakes world of oil and gas is just completely reimagining safety training.
From the ground up.
Right. We're talking about ditching those dusty old binders and replacing them with a fully interconnected ecosystem of verified, playable 3D simulations.
It's a total shift in how we prepare human beings for worst-case scenarios.
It really is. So, welcome to the deep dive. We are going to cover a lot of ground today, starting with an industry where the stakes literally could not be higher.
Yeah, so when we look at the July 2026 release, they outline the completion of this EON Situation Room for oil and gas.
Okay.
And this is a catalog of 120 detailed safety courses. But we really have to look closely at the specific terminology they use to describe the curriculum.
Right, because these aren't your typical HR videos.
Exactly. They aren't built in these massive 3D simulations just to, remind you to hold the handrail on the stairs or how to lift a heavy box without hurting your back.
No. The list of scenarios they provide is intense.
Very.
We are talking about stored pressure release during lockout, runaway chemical reactions, BLEVs, well blowouts, arc flash, and toxic gas releases.
Just absolute worst-case stuff.
Okay, let's unpack this. To put this into perspective for you, think about standard safety training as reading, like a paperback book on the aerodynamics of a commercial jet.
Sure.
What EON AI Ventures is doing here is building the ultimate, fully immersive flight simulator for industrial workers who might suddenly find themselves facing, a toxic gas cloud.
That's a great analogy. And I want to focus on one of those hazards to really illustrate why this specific list matters so much.
Yeah, please.
So you mentioned BLEVEs earlier.
Yeah, the BLEVE.
Right. For anyone outside the industry, that stands for Boiling Liquid Expanding Vapor Explosion.
Sounds terrifying just saying it out loud.
Oh, it is. A BLEG isn't just a regular fire. It happens when a pressurized tank of liquid is heated from the outside, maybe by a nearby fire that's already burning.
Okay, so the tank is getting cooked.
Exactly. The liquid inside starts to boil, the pressure builds, and eventually the steel tank itself loses its structural integrity.
And the split second that tank ruptures, all of that pressurized boiling liquid instantly turns into a gas, right? And it expands explosively. I mean, you don't have minutes to react to that. You have seconds before a shockwave just levels the entire facility.
Precisely. And that underlying physics is exactly why human psychology under extreme stress is the real variable here.
Because you can't just think your way out of it.
No, you can't. A runaway reaction, or a BLEVE, they're rapidly escalating high-consequence events. When an alarm goes off and a pressure valve blows, the human brain goes straight into fight-or-flight mode.
Adrenaline just takes over.
Your heart rate spikes, your peripheral vision narrows, and you simply do not have the cognitive bandwidth to try and recall, paragraph 4 on page 12 of a safety binder you read 6 months ago.
Right, like, what did the manual say about the red valve again? It's too late.
Way too late. Theory must instantly become muscle memory.
So if you're a pilot, you know what it feels like to lose an engine because you've lost an engine 100 times in the simulator.
Exactly. You've been there.
You've gone through the checklist while your hands are actually sweating. So if the hazard is that fast and that violent, a multiple choice quiz is completely useless.
Utterly useless.
You need a way to wire that panic response directly into the nervous system before the real thing ever happens.
Yes.
But how are they physically delivering that to a worker? The source material details what they call a three-engine architecture.
Right. So this is where we move from the theoretical curriculum to the actual delivery mechanism.
The how.
The how. One single, concise, roughly 20-page course is engineered to feed 3 connected systems simultaneously.
Okay, what are the 3?
First, there is the custom virtual campus that handles the structured instruction in the assessment.
Got it.
Second, the EON live real-time simulation runtime. And third, the EON Universal 3D Facility Platform.
Wow, okay, so they're taking one core source of truth and generating 3 totally distinct learning environments from it.
All working together, yeah.
The white paper details that every single course carries the correct step-by-step safe procedure, the failure modes, the early warning signs, cited safety standards.
It's very thorough.
It is. 12 or more exam questions, an oral interview, and finally, a scored simulation run that is mapped to a fixed certification weighting.
It's a deeply layered psychological approach. They aren't just throwing you into a 3D environment and telling you to, figure it out by trial and error.
Well, let me pause you there because I actually have to push back on this a little bit.
Okay, go ahead.
When you say playable simulation on a real 3D plan, I think a lot of people's minds instantly go to gaming.
Sure, video games.
Right. Like if I'm sitting in a climate-controlled office wearing a VR headset, I know I'm perfectly safe.
You're not actually on a rig.
Right. So how can a digital environment ever replicate the true adrenaline-pumping panic of an actual rig when the real alarms start blaring? I mean, it sounds like an incredibly detailed corporate video game. You click some buttons, you get a high score.
I get that. That is the natural skepticism anyone would have. But what's fascinating here is how they structure the progression you just laid out. It shows why it really isn't a game.
How so?
Well, the founder of EON AI Ventures, Dan Lajerskar, he frames this transition perfectly in the release.
What does he say?
He says, most safety training is something you read. Ours is something you read, are tested on, and then rehearse in a living simulation as many times as it takes.
Rehearse. That's a key word.
Exactly. A video game is designed to be beaten. A living simulation is designed for rehearsal.
So it's the friction built into the process that forces the cognitive shift.
Yes, the friction is intentional.
You don't just put on a headset and jump into the 3D plant right away. First, you get the structured instruction. You are tested with the exam questions. But then you face an oral interview.
That's the kicker. An oral interview requires you to actually articulate your understanding.
You can't fake that.
No, you can't just guess C on multiple choice test and hope for the best. You have to verbally prove to an examiner that you understand the underlying physics and the why behind the procedure before you are ever allowed to touch the digital controls.
Wow. So you are quite literally earning the right to run the simulation.
Exactly. And only then do you move to the scored live rehearsal. Think about how the adult brain encodes long-term high-stress memory.
Okay.
This whole process moves the learner from passive reception reading to active recall during the exam, to articulation during the interview, and finally to physical spatial application in the simulation.
So it's building on itself.
Right. The headset isn't there to scare you with flashy graphics. It's there to force you to physically move your body and execute the steps you just verbalized while the simulated environment degrades around you.
Right. Things are falling apart in the simulation. But, if I'm putting on a headset to practice surviving a well blowout, I need to know this isn't just some programmer's imagination, right?
It can't just be made up.
Exactly. A simulation is only as safe as the reality it mimics. If the software doesn't accurately reflect how a blowout actually happens in the real world, the company could end up training people to do the exact wrong thing.
Which would be disastrous.
Completely. So I'd assume they have to be pulling from real historical incident reports to make the physics accurate.
That's exactly what they're doing. They are looking backward to protect the future. The source explicitly states that these courses are grounded in real hazard mechanisms and the landmark incidents that taught the industry these lessons in the first place.
Okay, here's where it gets really interesting. The source names the historical anchors they used. And for anyone familiar with industrial history, these names carry an immense amount of weight.
Oh, absolutely. They are infamous.
Piper Alpha, Buncefield, Bhopal, Deepwater Horizon, which is also known as Macondo, Faison, Texas City.
Yeah, these are the big ones.
They aren't sitting in a boardroom inventing hypothetical bad days. They are painstakingly recreating history's absolute worst days.
And that matters so much because for a long time, incidents like Bhopal or Deepwater Horizon have just existed in training manuals as cautionary tales.
Just stories, really.
Right. You read a summary of what went wrong, you read the findings of the subsequent investigation, and you just shake your head at the failures in oversight or mechanical integrity.
It stays entirely abstract.
Totally abstract. It's a tragedy that happened to someone else in a different time under different circumstances.
You're just reading a post-mortem.
But what EON is doing here is extracting the exact failure modes from those incidents. They are programming this specific sequence of, a valve failing, a pressure gauge misreading, or a runaway reaction accelerating.
Building the math into the system.
Yes, and building a living simulation around those exact parameters.
Let's use Deepwater Horizon as an example of why this is so critical. In a traditional manual, you might read that pressure anomalies were misinterpreted by the crew in the hours before the blowout, right?
Right, just a bullet point on a page.
But in the EON Situation Room, the worker is placed in the virtual environment and they actually have to watch the digital gauges mimic those exact same anomalies.
They experience it.
They learn what the subtle early warning signs of a disaster look and feel like in real time, like 20 minutes before the final explosion even happens.
And that is powerful.
Yeah.
Because it transforms an abstract historical tragedy into actionable, applied knowledge for the user today.
You are basically giving these workers the chance to practice surviving history.
Practice surviving history, yeah. I like that.
You are standing in the virtual shoes of people who faced catastrophic failure, but you get to hit restart. You try again until you recognize the anomaly and get the procedure right.
It's incredible. But your earlier point is really the critical hurdle here. If a worker reverses a safety procedure in a living simulation, and the data driving that simulation is flawed,
Oh, man.
you have just hardwired a fatal mistake into their muscle memory.
Which brings us to rigorous quality control. How on earth does a company ensure that a catalog of 120 high-consequence courses is perfectly accurate down to the decimal point?
It's a huge undertaking.
The white paper highlights a concept they call independent adversarial verification.
Right, so every single one of the courses was rechecked by an independent party. They did a line-by-line comparison against the authoritative source material, incident by incident.
To put adversarial verification into a real-world analogy for you, think about how major tech companies protect their data networks.
Like cybersecurity.
Exactly. They don't just ask their own programmers if the firewall is secure. They hire ethical hackers, red teams, whose entire job, their sole objective, is to relentlessly try and break into the system.
Finding the weak spots.
Or think of it like a ruthless editor trying to find a fatal logic flaw in a manuscript. They aren't there to validate your work and make you feel good. They are there to stress test your code until it snaps.
And the release actually gives us the exact stats on how this adversarial pass went down.
What were the numbers?
So out of the 120 courses, 114 were verified clean right out of the gate.
That's a pretty good pass rate.
It is. 6 courses had minor citation or labeling slips, which were immediately corrected. But the metric that really matters here is 0.
0.
0 courses reversed or omitted a safety critical step, and no course required a safety escalation.
Wow. The language they use in the source material to describe this process is really fascinating, too. They state that this adversarial verification pass was done to ensure the material is trustworthy rather than merely plausible.
That is a very deliberate distinction to make.
Trustworthy versus plausible.
Because this raises an important question.
Yeah.
We have to analyze why plausible is such a dangerous trap in safety training today.
Especially now.
Exactly. We live in a world of generative AI and rapid digital content creation. It is incredibly easy to just prompt an AI to create a 3D training environment that looks and sounds plausible.
It looks real.
The terminology sounds right to the ear. The safety gear looks correct on the virtual avatars. The valves are painted the right color. To a novice, it feels authentic.
But plausible just means it could be true based on, surface-level patterns.
Right.
Trustworthy means it has been proven true under intense empirical scrutiny. I mean, in a high-consequence scenario, A lockout procedure that is merely plausible might be missing a highly specific counterintuitive step required for that exact piece of machinery.
It happens all the time in real life.
A plausible digital valve that turns clockwise when the real-world valve turns counterclockwise that will literally get someone killed.
It will. Adversarial testing doesn't care if a course looks good. It only cares if it is empirically correct according to the authoritative standard.
Right, the truth.
In our current era of information overload, insisting on adversarial verification is really the only way to build actual trust in digital training systems.
Clearly, that level of trust is exactly what they are banking on, because this entire 120-course catalog is complete and available right now for partner briefings and pilot programs.
They are ready to go.
And the source notes, they have additional industry verticals currently in development too, which forces us to zoom out from the weeds of oil and gas and look at the ultimate goal of the company behind this.
Yeah, the background provided in the release gives us a clear picture of their pedigree.
Who are they?
So EON AI Ventures was founded by the leadership behind EON Reality. They boast 25 years of experience in immersive learning, with over 4,400 institutional customers across more than 80 countries.
Okay, so they have a massive global footprint. This isn't a startup.
Not at all.
Yeah.
But it's their macro concept that really shifts the paradigm here.
Yeah.
The release introduces a concept they call work intelligence, or WI.
Work intelligence.
They describe this as the enterprise's missing system of record, capturing how work is actually done and turning it into an owned, compounding digital asset.
A system of record for physical work.
Exactly. They break this down into a one-system architecture with 3 parts. Human 2.0 is the vision, the intelligence flywheel is the engine, and work intelligence is the asset.
So what does this all mean? I mean, decoding all this corporate jargon for a second.
Sure, if we connect this to the bigger picture, it is a masterful synthesis of where enterprise technology is heading.
How so?
For decades, companies have digitized their finances, right? Their supply chains, their human resources data.
All the spreadsheets.
All of it. But the actual physical execution of complex, hazardous work has largely remained analog.
Oh, that makes so much sense. Think about your own workplace. If the person who has been doing your job, or maybe a highly specialized job in your company, for 20 years if they retired tomorrow, how much of their intuitive knowledge would just walk out the door?
Most of it.
It's the veteran on the oil rig who just intuitively knows how a specific valve sticks in cold weather. When they leave, that knowledge vanishes.
Gone forever. What EON AI Ventures is doing with this architecture is digitizing human expertise. Work intelligence is the digital capture of that expertise. When you have workers rehearsing in a living 3D simulation, you aren't just training them.
What else is happening?
You are tracking every decision, every physical movement, every hesitation, every reaction time. The simulation is learning from the worker, just as much as the worker is learning from the simulation.
Ah, and that brings us to the intelligence flywheel they refer to.
Yes.
In physics, a flywheel stores rotational energy. The faster it spins, the more energy it stores, and the harder it is to stop.
Right.
As more workers train in the Situation Room, the system gathers massive amounts of data on how work is actually executed by human beings under stress.
Exactly.
The training gets sharper, the workers get safer, and the company builds a deeper, richer digital asset.
That compounding knowledge is the flywheel spinning faster and faster, and that naturally leads to their vision of Human 2.0.
Which sounds a little sci-fi, I won't lie.
It does, but it's not about replacing the human worker with a robot.
Okay, good. It makes me think of how crowdsourced traffic apps work.
Oh, that's a good comparison.
Right. You aren't just relying on your own eyes to see a traffic jam. You are relying on the digitized, real-time experience of thousands of drivers ahead of you.
Yeah, exactly.
If 50 cars ahead of you hit their brakes, your map turns red. Human 2.0 is that same concept applied to industrial safety. You are augmenting the human worker with the compounded, digitized experience of every single person who has ever faced that high-consequence scenario before them.
That's spot on. You are no longer just hoping your workforce remembers what they read in a 20-page manual.
Hoping is not a strategy.
No, it isn't. You are capturing physical, hazardous work, validating it through adversarial verification, and turning it into an owned, compounding digital asset that ensures the hard-won lessons of the past are never, ever forgotten.
It really is incredible when you trace the whole journey we've just taken today.
It's a huge shift.
We started by looking at a company that looked at the traditional passive way we train people for the most dangerous jobs on Earth and just decided it wasn't good enough.
It wasn't saving lives.
They took the absolute darkest moments in industrial history, the catastrophic lessons of Piper Alpha and Texas City and Deepwater Horizon.
They extracted the exact failure mechanisms and early warning signs, ran all of that raw data through a ruthless adversarial verification process.
The ethical hackers.
Exactly, to ensure every procedure was empirically trustworthy and output a catalog of living simulations.
Simulations that force a worker to read, test, verbally articulate, and finally, physically rehearse their survival in a 3D plant.
Turning reading into rehearsal.
They were literally turning reading into rehearsal. But, building that intelligence flywheel leaves us with a truly fascinating thread to pull on regarding the future of work.
It really does. Every physical movement, every split-second decision, and every intuitive reaction in these high-stakes simulations is perfectly tracked and captured by the system to create a compounding digital asset for the enterprise, who ultimately owns that expertise.
Ooh, that's a tough one.
Is the expertise owned by the human worker who bled, sweated, and learned on the job over decades? Or is it owned by the living simulation that learned from them, perfectly digitized their instincts, and turned it into corporate property?
Something for you to mull over the next time you log into a training module or rely on your own hard-earned instincts. Thank you so much for joining us on this deep dive. Keep questioning the world around you. Keep looking for the why behind the information, and we will catch you next time.